63. All right, so we are going to graph the rational function. So before I graph, the first thing I have to do here is do what? We have to factor, yeah. If you want to get some colors, there should be pencil sharpener. You don't have to use colors, that's up to you. But there's pencil sharpeners, hopefully in the box too. If not, you can get it from the back counter. And so I'm going to factor. Numerator is going to end up being x, what? Minus 3 and x plus 1. And then I'm going to get down here. I'm going to get x plus 1 and x plus 2. Right? So do I have anything that will cancel? Yes, I do. So I can cancel out the x plus 1s. That'll give me a negative 1 for my x value. Then f of x is going to equal x minus 3 over x plus 2. And then that means my y value for my point discontinuity would be what? Negative 4. So I guess it becomes negative 1 minus 3 over negative 1 plus 2, right? So that ends up being negative 4. All right, so what are my zeros? Positive 3. And do I have any vertical asymptotes? Yes, I got this right here is going to give me x equals negative 2. Do I have any tangency or togetherness? No, because I don't have any multiplicity anywhere, so this would be none. Do I have a horizontal asymptote? Yes. What is it? Y equals 1, because they are tied in degree. So y equals 1, which means I can't have a slant asymptote, so that is none. Then my y-intercept is going to be 0, what? Negative 3 over 2. So remember, that's real easy to do. We just ignore the x's, pretend like they're zeroed out, and you're just left with negative 3 over 2. That's it. Okay, so I'm going to rewrite my function right here because when I scroll, I can't see it. You don't necessarily have to rewrite yours. Minus 3 over plus 2. Okay, so that's my number line. Number line, I put my zeros and my vertical asymptotes. So negative 2 and a 3. And remember, I don't care about open circles, closed circles. I'm not even putting points there because I'm not looking at just one or the other this time. I want to know everything. So I substitute in a negative 3. That's going to give me negative over negative, which is altogether positive. Between negative 2 and 3, it is, I can pick 0. So negative positive will be negative. Substitute in 4, and that'll give me positive positive. So what I'm looking at here is that this is my function's positive there. It's negative here. It's positive here. Then I'm going to go over here and I'm going to graph everything I can graph so far. Let's see, I have point discontinuity at negative 1, negative 4. So I'm going to put an open circle there. Then I have a 0 at 3. And I have a vertical asymptote, x equals negative 2. And horizontal asymptote at y equals 1. And then a y-intercept at 0, negative 3 halves. And negative 3 halves would be, what's the value? Negative 1.5, right? Right there. So I have 3 points plotted, like 2 points and an anti, but I have 3 things plotted there. And then I need to see if I can figure out what my graph is supposed to look like. Because remember, we don't really know what it's supposed to look like. Sometimes they look similar to each other and sometimes they don't. Here's what I know. From negative infinity to so it's somewhere in between these asymptotes. But I have no idea where any points here at all. We'll get back to that in a minute. Between negative 2 and 3, so between negative 2 and 3, my graph is negative, which makes sense because I've got these 3 points here, so I think it's going to look like that. And then between 3, or from 3 to infinity, it's positive, so it should be coming up here on this side of that asymptote, right? So we need to focus over here where I know nothing. In each section of your graph, you have to have at least 1 point. Sometimes you're going to need more than 1. But since I have this asymptote at -2, we'll just try a point right on the other side of it, and we'll make a little t-chart, and we'll try a -3 and see what happens. So when I substitute in my -3 to this function that we can only partly see now, we give me -3 minus 3 over -3 plus 2. Me so far? This is going to give me -6 over -1, so what do I get? So I can go graph that, and I can go to -3. 1, 2, 3, 4, 5, 6. Well, I don't know that that point really helps me that much, because here's what I know. It could come really close to the asymptotes like this, or it could swing way far out like this. Like, I feel like I need another something. So I could pick -4, -5. Let's just go ahead and go all the way to -6 and see what happens. Doesn't matter what you pick. Those were just the ones that happened. Not because they're special and I know what's going to happen. That's just what I picked. So this would give me -6 minus 3 over -6 plus 2, right? So what's -6 minus 3? -9 over -4, which gives me 9/4, which we're going to get lots of fractions over here. That's fine. It's not that bad, because here's what happens. How many times does 4 go into 9? 2, with 1 left over, so it's like 2 1/4. I'm not even writing that down. That's just where I'm going to go and graph that. So at -6, 2, 4, 6, I go to 2 and about 1/4, which is like right there. Okay, so now that I have those 2 points, I feel a little bit more comfortable about sketching this in, and I can sketch that in right there. In each, like in this section, you only have to have 1. So if I'd have picked like -4 instead of -3 instead, I might have gotten something where I feel better about just having that 1 point. Sometimes you're going to want to. I think it'll be pretty obvious to you whether or not the 1 point you get is enough or not. And maybe after we do a few more, you'll kind of see how that works. So then in this section here, do you feel like you need any more points? No, I feel like it's probably fine, and it's going to look like this. Okay. Everybody okay with all that? Any questions? All right. Good. All right, let's try the next one. Go to number 2. I know the numbering is weird on here too, but find number 2. You don't necessarily have to. In the end, you're going to fold it. If it's not folded right now, it's fine. All right, so number 2, I'm going to start off by factoring it. So I factor the numerator, and I'm going to get x minus 3 times x plus 2. Denominator, you factor it and tell me what you get, but just don't scream it out yet. Get everybody a chance to factor it. What's it going to be? X plus 4 squared. Yes, it is x plus 4 squared. All right, so it is a perfect square trinomial, so it is x plus 4 squared. If you don't notice the factoring process, it's not the end of the world. Just know when you get x plus 4 times x plus 4 that you need to put it together. Okay. All right, so that's what we end up with. Can I reduce anything? So my point discontinuity, there's none. What are my roots here? -2 and 3. Good. Do I have any vertical asymptotes? Yes, I do. That would be x equals -4. Tangency and togetherness. Is there any of that? Yes, I got multiplicity, and it's in the denominator. So is that tangency or togetherness? It's togetherness, because your tangency is in the numerator, and your togetherness is in the denominator. And if you always say them together, tangency and togetherness, numerator, denominator, you'll get them in the right spot. So this means I have tangency. Oh, I don't. Yes, I do mean togetherness. Thank you. I want to see if you were paying attention. Good job. You were paying attention. Very good. So togetherness at x equals -4. So if I had tangency, I'd put tangency at x equals whatever. So it's at the x value, and then we'll use that later. All right, so then my end behavior, do I have a horizontal asymptote? Is it bottom heavy? What's the degree? Yeah, the degree of the numerator is 2, and the degree of the denominator is 2. So they're tied in degree. Even though this only has one little set of parentheses, it's still 2 times there. So this is still 2 over 2, so they're tied, which means y equals 1. My y-intercept is going to be 0 what? Good, negative 6 over 16. Looking at this form makes it a whole lot easier than looking at that form, because all my x's zero out, so I'm left with negative 6 over 16, and that reduces to negative what? 3 over 8. Then I'm going to scroll. And I'm going to rewrite my function so I can see it down here. F of x equals x plus 2 times x minus 3 over x plus 4 squared. Okay, so on my number line, I have negative 4, negative 2, and 3. Substitute in a negative 5 right here, it's going to be negative. Negative 5 right here, it's going to be negative. What's going to happen in the denominator? It's going to be positive. Is it possible for me to substitute anything in and make that denominator negative? No, because it's going to square it. So this basically I can ignore it, right? If it's positive, it doesn't change the sign. So the only thing driving the signs here is the numerator. So that's all I need, and that's positive. If I substitute in a negative 3 here, this is going to be negative, negative, which is also positive. Right? And then between negative 2 and 3, I can use 0. That's going to be positive, negative, which is negative. Substitute in a 4, positive, positive, which is positive. So our signs have been alternating a lot, right? These didn't alternate because they don't alternate every time. That's why we have to do this. So positive, positive, negative, positive. Now, let's think about what's happening here. At negative 4, what do we have? We have together. At negative 4, there's a vertical asymptote and there's togetherness. What that togetherness means is that the branches go in the same direction on either side of it. They're both going to infinity like that. At negative 2, there's a 0, right? So I'm going to cross through the axis. Between negative 2 and 3, I'm negative down here. That's another 0. And then it's going to go on for infinity like that. But that's what that togetherness means. Does that make sense to you? So that's helping us what we're going to graph on there. So let's go graph everything we can graph. I don't have any point discontinuity here. I have roots at negative 2 and at 3. Vertical asymptote at negative 4. I also have togetherness, which we'll come back to that. I have a horizontal asymptote at y equals 1. And I have a y-intercept at 0, negative 3/8. So negative 3/8 is really, really close to what? 1/2. So that's like, and these boxes are so small, 0, negative 1/2. I mean, just a little less than that, ballparking it just fine there. Okay, y'all good with that? Any questions? Looks inappropriate. Okay. So now let's look at what's happening with this. Between negative infinity and negative 4, my graph is positive, so it should be up here somewhere. From negative 4 to negative 2, it's positive, right? And then from negative 2 to 3, it's negative. So it's going to drop down here, which makes sense. And 3 to infinity, it's positive. So what looks like what's going to happen here? Anything? It's going to go through your asymptote, right? And we'll address that in just a minute, but that's actually okay. We'll get to that too. But let's handle this part of the graph first, right? And we are going to have to substitute in some numbers. I got nothing there, right? So my x and my y. And so I'm at negative 4. I'm going to try just one on the other side. We'll do negative 5. So if I substitute negative 5 into here, that's going to give me negative 3 times negative 8 over negative 1 squared. Do you see how I'm just doing that math when I substitute it in? Make sure I'm not losing anybody. So in the end, is this positive or negative? positive, right? Okay, so 3 times 8 is 24, and that's just 1, so negative 5, 24. Oh, I almost wrote 25. 24. Does it really help me any? Nope, because that's way off my graph, right? So next, let's try negative 6. So when I substitute it in, I'm going to get negative 4 times negative 9 over negative 2 squared. All right, so again, in the end, I can just not worry about the signs. Isn't that going to be positive? Kind of ignore the signs. Well, 2 squared is 4, so that's going to cancel out with that, right? And that just means that's a positive 9. Can I graph that one? Yes. So we'll go to negative 6, 9. Well, because that one's so far up, like if I just had 1, but it was closer to the intersection, it's going to help me some more so than that. So instead of just going to 7, negative 7, let's go ahead and jump to negative 8. See if that point will help me some more. Like that's helpful, but I need something else. So when I substitute a negative 8, it's going to give me negative 6 times negative 11 over negative 4 squared. 6 times 11 is 66 over 16, right? Don't let the fractions freak you out. It makes you stronger when you can do this. Can I reduce this? Yeah, they're both even, so I can make that 33 over 8, right? Okay, and then I can't reduce it anymore, but that's okay. Well, not pretty and you don't like it, but you'll be fine. 33 over 8. So then you just figure out what that means. How many times does 8 go into 33? 4 with 1 left over, so that's 4 and an eighth, right? So I go to negative 8, and then 4 and an eighth, 1, 2, 3. That just means 4 and a tiny little bit, because that's the best we can do. And then I'm going to sketch that in, and it looks something like that. Okay, so there's that section of the graph. That's between negative infinity and negative 4. So then we have this togetherness, which means since this is going up to infinity, the branch that's right here has to look like this, because it's supposed to be going in the same direction on either side of the asymptote. Well, there's no discontinuity, like there's no jump discontinuity or anything like that unless we have piecewise. So this is going to come all the way down. I have to hit that x-axis right there. It becomes negative, and then it becomes positive again. So when I do that, and I get that much right there, I cross through that asymptote, which is what we thought might happen. And I haven't finished my graph, but it does cross through the asymptote, and that's okay. Asymptotes, the actual definition of them, isn't something that you can just never cross. Now, for rationals, we are never going to cross the vertical asymptotes because that affects your domain. The horizontal asymptotes, though, you could cross once, twice, an infinite amount of times. It's not about what's happening in the middle. It's about end behavior. So in the end, this will be approaching 1, even if I cross back through a few times. But what I need to know now is if I'm going to cross it again, right? So if I'm going to cross, if I'm supposed to come back up here or not, because I don't have anything that's going to tell me that. So you have your rational function, which is what I'm graphing in purple. This horizontal asymptote is a line, which is also a function. You agree with that? So do you remember one of the ways that you can solve systems of equations is graphing, right? To see where two things intersect, you graph them both and you see where they intersect, right? But then algebraically, you have to do substitution or elimination or something like that. So here, you've got your function, which is this x squared, what do we have to begin with? X squared minus x minus 6 over x squared plus 8x. At f of x equals this. This is my rational function. Oh, thank you. Dang it, 16. This is my rational function. And then my function that is asymptote. I substitute in, instead of y equals this and y equals 1, I substitute this in for y. I've got that equals 1, right? Now I need to solve that and see when that is true. When all does this function equal 1? I know one of the times, but I got to figure that out. So I just multiply both sides by the denominator to get rid of the fraction. So that'll give me x squared minus x minus 6 equals x squared minus 8x plus 16. Everybody with me so far? Now I'm solving this, so I subtract x squared from both sides and they cancel out. Dang it, I know, I'm really shaking. Thank you, plus 8x, what the heck? I've been off just all day today. Thank you. All right, so then I'm going to add x to both sides to this over here. So that'll give me negative 6 equals 9x plus 16. Then I'm going to subtract 16 from both sides and get negative 22 equals 9x. So x equals negative 22 over 9. So let's think about what all this tells us, because this tells us a few things. Number one, that we're going to cross the asymptote, which we already knew. Number two, how many times do I cross the asymptote? Did I mess up again? Okay, wait. Okay, where did I lose you then?
Oh, you added x. That's what you did.
Yes, I added x. I just didn't write that. Yes, I did plus x and plus x. Sorry, I thought I messed up again. That's where that came from. You got me now? Okay. So we know that it's going to cross, which we already knew. And since I only got one x value, it only crosses one time, right? That's for the negative 22. Sorry, I didn't show all my work. So. But I do know that I'm right at the end. I do know that this is the answer. All right, so at negative 22 ninths, which is negative 2 and 4 ninths, right? Which is like negative 2.5. So when x is negative 2.5, that's when I cross the asymptote, which should be right about where you crossed, even though we didn't even know that that was the actual number, right? So that's the only time it crosses, which tells me that when I finish graphing this, it's not going to cross back over. Instead, it's going to just come up like this and get closer and closer to that 1 as we go along. Okay? So that looks kind of nothing like the rest of the ones that we did, right? And that's what you need to understand, is that you may start to think, hey, they're all going to look like this, and they're not. But we know what's happening based on our sign charts, where it has to be positive and negative, where our intercepts are, and all that good kind of stuff. Don't be afraid of this stuff. If you can fill out this charts and everything, you should be able to translate your knowledge of what's going on over here to what's going on in the graph. Okay? Are we good? Any questions at all? All right. Let's try number 3. So we're going to factor. It's going to give me x minus 1 and x minus 3 over x minus 2. Can I simplify anything here? No. So I have no point discontinuity, so that's none. My zeros are at what? 1 and 3. My vertical asymptote is at x equals any tangency or togetherness? No, because there's no multiplicity, no even multiplicity, so this is none. Do I have a horizontal asymptote? Well, they're not tied in degree, so I know it's not the ratio there, but it's top heavy, so that means this is no. So why are a slant asymptote? Yes, and I need to go and find it. I find it by division. Maybe long division, maybe synthetic division. Can I use synthetic division? Yes, then that's what I want to do. On the outside, I put a 2. On the inside, I'm using this. So if it hadn't been multiplied out, I would have to multiply it out to get that version. This is going to be 1, negative 4, and 3. So I bring down the 1. This is 2, negative 2, negative 4, and then I don't even care about that. So my slant y equals x minus 2. Good. And then my y-intercept, this helps me with that y-intercept as well. It's going to be 0, what? Negative 3 over 2, negative 3 halves. Any questions at this point? Okay, good deal. On the bottom, then I'm going to rewrite this so I can see it. And this I want the factored form down here. Be x minus 1 times x minus 3 over x minus 2. So on here I put the 2 and 3. So I can substitute in 0 here. It's going to give me negative, 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 negative. This is going to give, if I substitute in 1.5, it's going to give me positive, negative, negative. 2.5 is going to give me positive, positive, positive. No, it's not. Sorry. What is it going to give me? Positive, negative, positive. Yeah, duh. Positive, negative, positive. And then 4 would give me positive, positive. This is negative down here. then positive, then negative, like that. Okay, so then let's plot everything we can. I'm going to get, I have no holes. I have roots at 1 and at 3. And then vertical asymptote at 2. Have a slant asymptote of y equals x minus 2. Very simple to graph because your slope is what? 1. And so you go to negative 2 on the y-axis, and then when your slope is 1, you can diagonals of the squares that are in the grid. And then 0, negative 3/2 is 0, negative 1.5. All right. From negative infinity, my graph is negative. So starting out, starts off with 1. And this is my asymptote, so it's the asymptote right here, right? From 1 to 2, it's positive. Okay, here's the vertical asymptote. So it's going to come up this way, and then it's just going to go straight. Because there is no togetherness, I know I don't start back over here on this side of the that side of the asymptote. I have to start down here. Plus, between 2 and 3, the graph is negative. So it's negative. It's going to come up and cross the x-axis right here. And then it's positive all the way to infinity, and I have an asymptote right there. So it'll just go with the asymptote. So I have plenty of points graphed, okay, to get the general shape of what's going on. But you have to make sense of it with that sign chart. So my graph is negative, 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 and then it's positive as it goes next to that asymptote. Then starting at 2, it's negative, goes through 3 on the x-axis, and then shoots up like that. And there's your graph. Make sure I can clearly see that you have actually plotted points and they don't look like microscopic dots that you just lucked out that were happen to be on your paper. They don't have to be ginormous, but some people it's literally like they took a pencil and went boop like that, and that's not good enough. We good? All right, last one. So, got a factor. Negative 6 in the numerator. It's going to be x minus 3, x plus 2. There's clearly nothing to reduce, so this would be none. My zeros, none. Do I write none? No, what do I do? Empty set. Very good. There are none because numerator 0. Notation. That's what you need to put. So is going to be x equals negative 2 and x equals 3. No tangency or togetherness because there's no multiplicity there. Do I have a horizontal asymptote? Yes, it is bottom heavy, so the answer is yes. So that would be y equals what? 0. Good. Then there is no slant asymptote. Y-intercept, 0, negative 1? Because these are going to zero out, so you got negative 6. All right, and look at the sign chart. It doesn't, if you plug it into the factor, you're going to do some work. Like it have to be negative 6, 3 times 2. But if I substitute it to this one, basically it just zeros out the x in it and just leave it with it. So it's like a little easier and shorter to do it in the one that's multiplied out, but you get the same thing either way. Just make sure you do it after you've reduced if anything knocks out. So like if I had crossed something out here, I don't want to go back to this form because I crossed something out of it. All right, so then number line, let me rewrite this. F of x equals negative 6 over x minus 3 times x plus 2. Okay. Yes, absolutely. Very good question. So his question was, will that negative 6 count as a negative every time? And the answer to that is yes, because once we put that on here, when I go and substitute numbers in, no matter what happens down here, that's being divided into a negative number every single time. So yes, the numerator is negative every time you putting that there. And then you have to determine what's the denominator. So -3 would give me negative in the denominator. So overall that is negative. Between -2 and 3, start with the negative in the numerator, and then negative, positive, which will give me positive. If I substitute in a 4, start with negative in the numerator, positive, positive, so it's negative overall. Graph looks like this. Everybody good so far? All right, so let's plot everything we can here. We've got no holes, no zeros. We have a vertical asymptote at -2 and one at 3. And then no tangency and togetherness. I have a horizontal asymptote at y equals 0 and a y-intercept at 0, 1. All right, so I got lots of asymptotes, and I only got 1 point plotted. But think about what's happening with our graph. From infinity to -2, my graph is negative. -2 to -2, it's all down here. I know I'm crossing this out. So it's all down here, which means something like this. But I'm going to have to get at least 1 point to know if it's way out here or if it's way in here, right? Do that point, we'll use -3. So if I substitute in a -3 here, I'm going to get -6 over -6 times -1, right? -3 minus 3, -2 plus 2, which means this cancels out to give me 1, but is it going to be positive or negative in the end? Negative. So -3, -1 is a point. Would you say that point's probably enough to get our shape? Yeah. In this case, that 1 point in that section is fine because it's, ooh, sorry, it's bouncing again. I don't know what they're doing up there. So it looks something like that. Make that bigger so I hit it. So then between -2 and 3, between these two asymptotes, the whole thing is positive. Between two asymptotes, the only shapes you can have is something that looks like a quadratic or looks like a cubic. Okay? If it goes on both sides of the axis, it can't be a line because the lines would poke through, right? So that's why you would have to have like the point of inflection like that. Or it's going to look something like a cubic. And since it's all positive between here and here, what's it going to look like? I think I just said it looks like a cubic. I meant quadratic. The wrong word came out of my mouth. Sorry. I did this. It's going to look like this, which is a quadratic, not a cubic. Sorry about that. So really that 1 point's probably enough, but we're going to find another one just for fun, just for kicks. So we're going to do +1. So if I substitute in a +1, I'll get -6 over -2 times 3. So what does that give me? 1. So yeah, I know. You were answering a different question. But so if I go to 1, 1, there's that point right there. So I know neither one of those is the minimum. The minimum's in here somewhere, but I don't know where, and that's fine. But it's going to look like this. Okay. Then from 3 to infinity, the whole thing is negative again. So again, I'm down here, but I don't have a single point to go by, so I need to figure that out. I will substitute in a 4. That's right on the other side of that asymptote. And when I substitute in that 4, it's going to give me -6 over 1 times 6. What's that? -1. So I go to 4, -1. Do you think that's enough? Yes, because it's going to have to hug these asymptotes like so, and that's your graph. So even that one that's kind of weird, just understanding the pieces that you have and throwing in a few more points, we got enough to get it right. Okay? Any questions at all? All right. Now, I know that the notes look weird and you're thinking, how am I going to glue these or tape these in? But I'll show you in just a second. So just fold it in half, make sure the ISN page is on the front.